Hello and welcome to my YouTube channel. Today we are going to discuss the introduction to dimensional analysis. Dimensional analysis is a process of expressing derived units in terms of basic fundamental quantities. As you all know, as I said earlier, in mechanics we have basically three basic fundamental quantities. We have mass, we have length, and we have time. So in dimensional analysis, basically we are going to express those derived units in terms of basic fundamental quantities. So the common notation of dimension of a quantity is a square bracket. The common notation of dimensions of quantity is a square bracket. As you can see, this square bracket, the meaning of this square bracket is dimensions of. This square bracket means dimension of. So this is a symbol of dimensions of. As you can see, dimensions of basic fundamental quantities. As I said, basic fundamental quantities in mechanics, we are going to look upon length, mass, and time. So this means if you see the letter L inside this square bracket, that means dimension of length. If you see brackets and M inside, that means a dimension of mass. And also if you see time T in brackets, that means the dimensions of time. So if you look at these things, you see that this is a dimension of basic fundamental quantities. Now, as we said earlier, that dimensional analysis is the process of expressing derived units in terms of basic fundamental quantities. So we are going to express derived units in terms of these fundamental quantities. So we are going to look upon the dimensions of derived quantities. Okay, we are going to look on force. Force is the same as mass times acceleration. As you all know, what is the definition of acceleration? Acceleration is velocity over time. Okay. Mass times velocity over time. What is the definition of velocity? Velocity is distance over time, or you can say velocity is length over time. Okay. I'm going to simplify this. Length over time over time. This means length over t negative 2. As you can see, it means length over t negative 2. Simple mathematics. Okay, I'm going to clear that. So that means mass times length over 2. We get mass, length, t negative 2. T power negative 2. So that is the dimension of force. So when we are expressing force, in terms of basic fundamental quantity, we are going to say mass, length, and t power negative 2. So that is a dimension of force. As we have already done the process of dimensional analysis on force, as you can see. Okay, we are going to another example. And now we're going to look upon pressure. Pressure is force over area. As you can see, in the previous example, we have already gotten the dimension of force as m, length, mass times length times t power negative 2. So in this dimension of pressure, also force will be mass times length times t power negative 2 over area, which area is length square. So this is very simple. We are going to simplify it. Mass, length, t power negative 2 divided by length power 2, as you can see. So length and length will cut off. So here, this is length power 1. You can just you can put it in your head that is length is power 1, and down we have here length power 2. So when you simplify, you get that when you simplify this and this, you get that here our length is power negative 1. Length is, you see that length is negative 1 if you simplify. As you can see, length is ml negative 1 times t power negative 2. So that is the dimension of pressure. So we're going to another example, and the next example will be power. So power is the same as work done over time. What is work done? Work done is force times distance. Force times distance, which is the distance is the same as length. So what is the dimension of force? We have already gotten it in the previous example, which is mass times length times time power negative 2 times length over time. So what you're going to do here is we're going to see that mass times length power negative 2. So that will be m l square t power negative 2, as you can see, times t power negative 2, and if we divide by t, that means it will at the end of the day you get that if you simplify, as you can see, mass, length, if you simplify this, you end up getting mass, length, and t power negative 3. So that is a simplified way. As you can see, you end up getting mass, length power, I forgot to write here power 2, t power negative 3. So that is a simplified way. So this video, basically we have expressed the derived quantities in terms of basic fundamental quantities. Thank you very much. So that is the end of our lesson for today. Please, you can like, share, and comment on this video. Thank you very much. Bye.